Hello, am I audible? Hello, am I audible? Okay, welcome everyone. So, those who don't have any prior programming knowledge, can you just raise your hand? Like you don't know even a single programming language. Is there anyone? Okay, so everyone has some knowledge. That's great. So, we'll be starting with the introduction to DSA. Like you don't know even a single programming language. Is the screen visible? Okay. So, welcome everyone. We'll be starting with the curricular course of DSA. We are from COC. So, let's start. So, first question that arises in our mind whenever we try to learn something is why should we learn it? So, why learn DSA? ऐसा क्या मिलेगा हमें? So, first of all, everyone of us is aspiring to work in great companies, and we'll be going into corporate world, and there will be solving variety of problems, and for solving those, we have to write efficient solutions. Now, how do we design these solutions? Like it's not like we think of an approach and move directly into its implementation. We have to consider the requirements, like how the data will be given to us, how will we handle it, like how long the algorithm will work on. So there are many factors into the play. So what DSA helps us is it provides us a structure on how do we approach the problem, how do we efficiently implement our solution in terms of algorithms, as well as choosing the appropriate data structures, so that it can be used by hundreds or thousands of users without any issues. And another point is, we don't know the size of the data that we'll be handling. So it may be very large. So for that, we need appropriate data structures, or maybe we need something like real-time access, fast access. So here the knowledge of DSA comes into play. Next is, I think many of you must be aware of the career benefits that DSA gives. That is, most of the top companies like Google, Microsoft, or Amazon ask DSA specifically in some rounds in the coding interviews. So for that, they evaluate you on the basis of how efficient your solution is, what approach you follow, like how exactly is your problem solving skills. Why they do that is they don't have any factor because of the lack of work experience. So for that, they use a neutral way of evaluating, which is your problem solving skills. So DSA is the way to go if you want to crack these companies. Okay, now it improves your problem solving skills, and if you want to participate in hackathons or pursue competitive programming, you must have a basic knowledge of the data structures and algorithms, so that you can solve any problem given to you based on those fundamentals. Now, where is it used in real time? So every day we use variety of features on the internet. For example, we search on Google, we use Google Maps for finding routes, or so we use social media where we get variety of recommendation. So all of these use the data structures one way or another for providing the outcome that we desire. Okay, so there are variety of data structures which are used based on our requirement. So this is just an overview of why we are learning data structures and algorithms. Now, moving on to course overview. So, what we are going to be studying in this particular course. So, starting with the fundamentals of data structures and algorithms, we'll be giving you an overview of what the data structures are and how they are implemented and how can you use them in solving the particular problem. And we'll be focusing more towards the implementation of them for solving the problems on platforms like LeetCode and Gigs for Gigs. And we'll be walking you through on how to optimize your code for achieving maximum efficiency. Okay, and how what different are we going to do? So I guess CSIT folks must be having a data structures course in their semester. So what we are trying to do different is we'll be focusing more on the real life implementation of the concepts that you'll be learning. Yeah, so we'll be guiding you on how to build up your intuition for solving the problems and how do you approach the problems, like how do you write the solution step by step. And yeah, that will be guiding you throughout the course. So by the end of this course, we'll expect you to have fundamental knowledge of the data structures and algorithms, and you'll be writing, you'll be able to solve most of the easy to medium questions on these platforms. And you won't be needing any prior knowledge about DSA, just basic programming skills. And coming to the programming part, we'll be sticking to C++ for solving the problems. However, the algorithms would be generic. So the users that code in different languages can try to code by looking at the algorithms. Okay. So this is the course structure that we are going to follow. It is divided into 8 parts, as you can see, and we'll be having a couple of lectures for each session, and we'll give you an overview of what these topics are and how are the general questions around it, and what are the general methods to follow for solving the problems for each topic. And you'll be getting assignments after each session for that particular topic, which would be evaluated further. We'll be discussing the evaluation in the next slide. So these are the topics that we expect to cover, and for deep understanding of these topics, you will have to explore on your own, because we don't have much time for covering each topic in depth. So yeah, we'll be having problem solving session for each topic, and you can ask your doubts over there. And this is the marks distribution for the course. It is divided into 4 parts: attendance, weekly assignments, mid test, and final test. The mid test and final test are not your MST and ESC. We'll be conducting it separately based on how our lectures go. Like the mid test would be placed at after around 4 to 5 topics, and the final test will be taken before ESC. Uh, your assignments would be evaluated, and yes, attendance will be taken into count, like whether you are attending the lectures or not. So make sure you attend all the sessions well. So this was about the course overview. Now we'll be starting with the DSA. So these are the four key concepts in DSA. It is data structures and algorithms, as well as the time complexity and space complexity. So Data structures. What comes to your mind when you think of data structures? Anyone? You can unmute or and say, or can type in the chat as well. Arrays, for example. Okay. Problems. How do you relate problems to data structures? I'm asking, what do you understand from the term data structures? You guys can unmute.
Collection,
Yeah.
collection and handling of data in a proper way.
Okay, great. Structures for use for organizing data. Okay. So data structures organizes and stores data efficiently for fast access and modification. So what does this mean? Imagine data structure as a container and data as your items. So you want to store those items in your container. Now, what particular container you choose will be depending upon what sort of items you want to store, or how do you want to store those items, like how in what format, or how many items you want to store. So these all factors play an important role in deciding the data structures for your particular use case. So we don't know the nature of the data. First of all, it can vary from being static to dynamic, as well as it can be in terms in the magnitude of tens or hundreds, or it can be in terms of thousands or millions. So based on these factors, we have to choose the appropriate data structure for our particular need. Okay, so we have a variety of problems, and for each problem the requirement may vary. So the thing is, for choosing appropriate data structure, we must know the requirements beforehand, and based on that requirement we choose the correct data structure. And for this you must have knowledge of like all the data structures present over there, so you can choose the most appropriate one. So coming to the types of data structure, let's say arrays. Somebody mentioned here arrays. Now arrays are used when the data is of fixed size and you need fast access. So consider some static data like numbers from 1 to 100. So for that you can use arrays to store these numbers, and we can easily access them using the array index. So arrays can be used for that purpose. Linked lists are used when the data is dynamic. That is, you don't that is, the data can change with time. So if we consider array, the data is static, we cannot change. So in the case of dynamic data, we use linked list. Similarly, we use stacks, queues, trees, and graphs for other purposes, which we'll cover on the sessions of those particular topics. Okay, so basically choosing the right data structure is really important, because that overall defines how efficiently the program is going to execute, how efficiently are you going to solve the particular problem. So like I mentioned, if you need fast access, we use arrays. If we need frequent insertions or deletions, we use linked list. And if we need order processing, we use queues. So these are just examples of the data structures, but overall choosing the right data structure is extremely important. Okay, because like the software you are going to build, it is not going to be just used by 10 or 20 people. It will be used by thousands or millions of people, so it must handle the load of all those users simultaneously. So for that, the data structures you used should be adaptable to that particular load or the input. So that's why it's really important. Now, moving on to algorithm. What do you think of algorithm? What comes to your mind? Yes, anyone?
It's the generic way how a program needs to be executed,
Okay,
independent of the language.
okay. Sequence of steps to solve a problem. Okay, particular template or approach. Process for solving a problem. Procedure of great. Everyone is correct. So, what is an algorithm? An algorithm is a step by step method to solve a problem efficiently. It takes an input, processes it, and produces an output. So, when you're given a particular problem, we must follow a particular set of steps. Yeah. So when we are given a particular problem, we must follow a set of steps to solve it. So let's say you are given a problem and you want to design the solution. You cannot straightly jump into the implementation part. Okay. So for that, we need to design the solution. We need to consider all the requirements and step by step mention it. Like what are the what things are you going to implement in that particular code. Now, each step should be clear and all the steps should be finite. Like if we, even if we give our algorithm to a person who does not have a programming background, he must understand what you are trying to achieve through your algorithm. It should be as generic as possible. Okay, and it should be correct. Like obviously, you need to solve the problem, so it has to be correct, and as well as it should be efficient. Now, what does efficiency mean? So here efficiency refers to the time taken for the algorithm to execute, as well as the resources the algorithm takes to give the required outcome. Okay, and it should solve a specific problem. Like your algorithm should be taking input and should be giving an output. So what it does is it solves a problem. Based on the input, it maps to a particular output. So overall, this is an algorithm, and an algorithm is written to solve the problem. So let's take an example. If you want to find the largest number from an array, what we do is we start with step one. We start with the first number as the largest. The next step, we compare it with the next number and update the largest number as the current number if it's larger. And the next step, we'll keep on repeating this until all numbers are checked. So it should be as generic as possible and it should be as clear as possible. Okay. Next, coming to algorithm analysis. Now, algorithm analysis refers to analyzing how good your algorithm is, like how efficiently it runs. So, based on given input size, how long does your algorithm take to execute? And why does it matter? So for a particular problem, you may have variety of algorithms, right? So how do you choose among them? So here algorithm analysis comes into play, and we evaluate each algorithm uh, based on the time it takes to execute. And of course, our main priority is our main priority is efficiency. It should utilize as less resources as possible. So we try to choose the algorithm which is most efficient, which takes least amount of time. So here algorithm analysis comes into play. And algorithm analysis is divided into two parts. First is time complexity, and next is space complexity. Okay, so why do we need time and space complexity? Not all code is equally efficient. Some programs run in millisecond while other takes minutes or even crash. So we all know there are different types of programs out there, and the runtime of each program is different. Okay, so consider an analogy where you are traveling to college. There are two routes, and first route we have a shorter distance and fewer signals, whereas the another route has longer distance and heavy traffic. So which one would you choose? Obviously route A, because it's faster and efficient. Why would you use a slower and inefficient route? So similarly, when we write algorithms, we must take into account the time it takes for that particular algorithm to execute, right? So like the algorithms that are used in top companies like Google, Netflix, they are very optimized, extremely optimized to handle a large amount of people. Also, we if you consider a very brute force approach, like it runs for a very large amount of time and consumes a lot of resources, so it's going to cause you a large processing time, as well as it will consume lot of resources. So it's inefficient to follow that particular algorithm. And of course, for coding interviews, the interviewer is going to require the most efficient solution that is out there for that particular problem. So you cannot submit just any particular solution. So, like, would you use Google if the search took 10 seconds? Or what if an ATM took 5 minutes to verify your PIN? So, yeah, so here the efficiency of algorithm is extremely important. Now, let's move to time complexity in algorithms. So, time complexity refers to the general time it takes for the particular algorithm to execute. It is divided into three main types. First is best case. So best case is like the minimum time an algorithm will run. Like it has to run these many iterations at the best. Okay, so let's consider an example of finding an element from a given array. Okay, so you iterate over the array, and if that particular element is the given target, then you break from the loop. Now, what would be the best case scenario of this algorithm? Of course, the best case scenario is that the first element itself is the target. So once you start the loop, the first element will be target and it will break. Okay. So it will take just a single iteration, and that would be in constant time. Okay. We'll come to the bigger part later. It is O of one time complexity. Next is worst case. Worst case is the, obviously as the name suggests, the maximum time the algorithm takes to uh, execute. So in this particular example, what if the target is missing from the array, right? It will scan the entire array and then it will break out of the loop. So it will take the maximum time, which is the size of the entire array. So which is of n. So it runs in O of n time complexity. Next is average case. Average case is the like meet. It considers the random scenario, like on an average, how many iterations it takes for the algorithm to execute to find the particular target. So on an average, if we consider, then it takes around n by 2 iterations if we consider the target to be in the middle. This is among all the possible scenarios. So average case, we consider it as n by 2, which evaluates to O of n. Okay. So as we mentioned here, this O of 1, O of n, O of n by 2, or whatever. So these are the methods, means of expressing the time complexity. So how do we express it, right? So this tells us, as the input size n grows, how many iterations will our algorithm take to execute? And it is determined by, of course, the number of iterations the algorithm performs based on the input size. So first is O of 1. What does O of 1 signify? It means that the algorithm takes constant time complexity. That is, the algorithm does not depend on n. So for example, consider this code. Here we have taken two numbers a and b, and we print their sum. So this particular statement gets executed once. It doesn't matter how large a or b are, right? So whatever large a or b are, it doesn't matter. It's going to execute in constant time in a single iteration. So we call this as O of one time complexity. Okay. This O represents the upper bound of the time taken by the algorithm. So at max, it will run in constant time, which is in one iteration. We just write the upper bound, right? Next is the linear time complexity. In linear time complexity, the number of steps are proportional to n. It means that like it will run for n times. As we increase n, the number of steps increases linearly. So consider this example. Here we take the input of n and we run the loop for n iterations. So this loop will run n times. Thus, the time complexity is O of n. This means that at max it will run n times. Okay, this is always the upper bound. Like it cannot exceed uh, the O of n time complexity. Uh, Another example is O of n square. Okay. So consider two nested loops, like there's a for loop within this for loop which runs for another n times. So for each iteration of the outer loop, the inner loop runs n times, which is n times n. So it runs for overall n square time complexity. Now, another example is log n. Now, this is a bit tricky one. Here, what we do is after each iteration, the problem size is reduced by half. What does it mean? So, consider this particular loop. Here we start from I is equals to 1 and we run the loop till I is less than equals to n. And at each iteration, we double the value of I. Okay, so first iteration it will be 1, next iteration it will be 2, 4, 8, 16, and so on. So how many iteration will it take till it reaches n? So it is given by log n to the base 2. Okay, so if we consider n is 16, it will run 4 times because log 16 to the base 2 is 4. If we consider 1 million operation, the loop runs only 20 times. Whereas if we consider the O of n algorithm, it would have run for a million times as compared to only 20 times. So this is the difference between the linear time and logarithmic time. So always the logarithmic time is better than the linear. Okay. And here is the comparison between the all general time complexities present out there, starting from constant. Like it does not depend on the input size at all, right? So it does not vary. Next is logarithmic, which takes a bit time, but it is extremely slow as compared to all the other algorithms. Next is linear time. As we mentioned, the for loop, which is O of n. It increases linearly as with respect to the input. Next comes the n log n. Next comes n square, which is the two nested loops. Then comes all the polynomial time complexities, which is n cube, n raised to 4, and so on. Next is 2 raised to n, which is exponential time complexity. We'll explore this in detail when we move on to the recursion topic. And the worst case is the factorial time complexity. So as you increase n, the number of iterations will increase in terms of factorial of the n. So it is the worst possible time complexity you can imagine. So this is just an overview of what time complexities are possible, and our main goal is using the algorithm with least time complexity that you can find. Now, consider an example where we have to find the sum of n natural numbers. So, in the first approach, what we do is we run a loop till n, and for each value, we add it to the sum variable. So, uh, for each number, we add it to the sum variable, and this will run till I is less than equals to n. So, this will run for n steps. So, overall, this evaluates to the time complexity of O of n, and this won't run if the n is this will take a large amount of time if n is very large. For example, if we consider n to be in the powers of 10 raised to 8 or 10 raised to 9, this will take like few seconds to run. So instead of this approach, what we do is we optimize it to make it run in a single step by using the formula of the sum of n natural numbers, which is n into n plus 1 by 2. So using this, we remove the need of a loop and replace it with a simple calculation which gets executed in a single step. Thus, the time complexity for this algorithm is O of 1. So here we efficiently improve the time complexity from order of n to order of 1, which is constant time. So this will run instantly even for 10 raised to 9 or n equals to 10 raised to 18 as well. Okay, it does not depend on the input. So this is just an example of how you can improve your solutions to get the least time complexity uh, from all the algorithms out there. Yeah, so whenever we solve problems on platforms like lead code or code forces or code chef, we are given the input in the form of n. Let's say we are given n numbers, so they are followed by the constraints imposed on those particular inputs. Like n would be less than equals to 10, and will be less than equals to 500, it will be less than equals to 10 raised to 5, and so on. So what this tells us that based on the given constraint, uh, which particular algorithms it would pass. Okay, like the algorithm with time complexities n factorial or 2 raised to n may pass for n less than equals to 10, but it won't pass for n less than equals to 500, because what happens is the editor, the platforms have a time limit of 1 second, and the modern computers run around 10 raised to 8 iterations per second. So if you consider that the 10 raised to 8 iterations are performed in a single second, your algorithm must run under single second, so it can run maximum of 10 raised to 8 iterations. So according to that, your algorithm, the time complexity of algorithm should pass for the given constraint. So here are the recommended time complexities, and based on the constraints you can run the algorithms with these particular time complexities. For example, n less than equals to 500, you can use n cube, which is 3 nested loops, or n square, which is 2 nested loops. Whereas for n less than equals to 10 raised to 5, you have to optimize the algorithms further. So O of n log n or O of n would pass for 10 raised to 5. Okay. Whereas for 10 raised to 9, you cannot even run a loop for the n, because it would give you time limit exceeded. So for that, we use O of log n or O of 1. So this is just an example of what how time complexities estimation would help you in solving the problems. Now, this was all about the time taken by the algorithm to solve the particular problem. Now, moving on to the space complexity. What is exactly space complexity? It is the amount of memory an algorithm needs to run. That is, whatever algorithm you're writing, it is going to need some memory to execute. For example, you are using an array or a matrix to store the particular elements, or you might be using some extra data structures which might require some extra memory. So these all data structures account for the memory usage of your algorithm. So based on that, we estimate the space complexity. It is given by the input space, that is the input data which is given, as well as the auxiliary space, the memory used for computation, for the extra data structures that you are going to use, or for the temporary variables recursion stack, which we'll learn further. So the total space complexity is the summation of all of these. Now, why exactly is space complexity important? We all know that the resources are we have are limited, and the memory of those resources, we cannot over occupy those memory. So for that, our solution the solutions we write must be as possible in terms of memory. Okay, because lesser memory usage means, of course, it will consume less resources, and less money would be spent in terms of managing them. And efficient algorithms use less memory, as well as they improve performance. Now, here comes an concept of trading time for space. For example, some algorithms solve the problem faster, but they cause higher space complexity. That is, they take large amount of space. So it complexity, and you can spare some space. So you can use a particular algorithm, as well as it goes vice versa as well. So it all depends on how what the requirements are and how do you want to approach the particular problem. Like there are variety of approaches available for the problem, so choosing the right one depends upon you. And yeah, now these are some examples of the space complexity. For example, consider the first one here. The only space we are using is the variable count which we have initialized, and it runs till it is less than equals to n. This will run n times, so there is no extra space used for this particular code. So the space complexity here would be O of 1, which is constant space. It won't increase with the input size. Next is the linear space. That is, the memory grows with input size linearly. For example, storing an array of size n, like given an input integer n, we store n integers in that particular array. So here the space complexity is O of n. That is upper bound for the memory taken by our program. Another example is n square, that is a 2D array, which is a matrix. Here we the data is stored in the form of a 2D array, which is of n cross n size. So each cell occupies one space, so it gives overall of n square memory. So the main goal of learning time and space complexity is that we must choose the algorithm which suits our needs at its best, right? Like we mentioned, I gets divided by 2. So can you all tell what would be the time complexity for this particular code?
Login,
Okay, so why exactly is it log n?
because every time it's getting divided into what two, right?
Yeah, it is getting hard, right? Base 2 is important because I'll explain it. Consider this particular code. What would be the time complexity for this? N by 3. Okay, anyone else? At each iteration, I gets multiplied by 3. It's not n. No, it's not cube root. Log n base 3, correct. At each iteration, I gets multiplied by 3. What we earlier saw is that I was getting multiplied by 2, so it was log n to the base 2. But for the current code, the I gets multiplied by 3, so it has to be log n to the base 3. Right? The base determines how slowly your algorithm is going to grow. Next, for this particular code, what would be the time complexity? At each step, I gets incremented by 2. Okay, n by 2, correct. However, when we see constants multiplied to the input size n, we often tend to ignore them. So here n by 2 is evaluated to O of n because we tend to get the upper bound of the time complexity, right? So even if it is 2n or let's say 5n, we consider it as O of n because it's just an upper bound, right? And let's consider this particular program. What would be the space complexity for this? Correct. It is constant space complexity because the initialization of array does not depend on the input size at all. So it has to be O of 1. Correct. Next, what will be time complexity for this particular code? The outer loop runs for n iterations. At each step, I gets incremented by 1. The inner loop, at each iteration, the j gets multiplied by 2. So for each iteration of the outer loop, the inner loop runs for log n iterations. So overall, the time complexity is n log n. Correct. Great. I see everyone has some decent understanding of the time complexity and space complexity beforehand. That's great to know. So let's try solving a problem. So finding the first repeating element in an array. Okay, we are given an integers and we have to find the first element that appears more than once in the array. Okay, and if no such element exists, we return -1. So what is the first approach that comes to our mind? Okay, so given an array, we need to find the first repeating element. So what we'll do is we'll just run a brute force solution. We'll run two nested loops and it'll find it'll compare if the two elements are equal, and if so, then it will return that particular element. Okay, so this checks for all the pairs present in the array. So the time complexity of this particular solution would be, yes, what would be the time complexity for this brute force solution? Okay, correct. It would take O of n square time. Now, and the space complexity is O of 1. Now, if the constraints were small, for example, let's say we are given n is less than equals to 10 raised to 3, then this particular solution would pass. But what if the constraints are large? That is, if we are given n is less than equals to 10 raised to 5, then would this pass? Definitely not. Right? So for that, we have to optimize it further. Now, second approach that comes to mind is, what if we use sorting? Now, after sorting the array, we know that all the elements are arranged in the form of uh, increasing order. So if there are duplicates present, we simply check it with the next element, and if they are same, we return that particular element. Here the checking is performed in O of n. However, the sort function takes n log n time, which we'll be discussing in further lectures, where we'll learn about the various sorting algorithms and how they perform sorting in the given time complexity. So overall, we take the larger time complexity, which is n log n. So this will take n log n time and O of 1 space. That is, we are not using any extra space in this particular code. So it would pass for almost all the possible constraints. For example, if n is less than equals to 10 raised to 6, this would also pass. Yeah, time complexity is n log n and space complexity is O of 1 because we are not using any extra space. Now, another approach is using hashing. What exactly is hashing, we'll be discussing in further lectures. For now, just assume it as a container in which we are putting elements, and we can check if an element is present in the container or not in constant time. That is, we do not have to iterate over all the numbers. So in O of 1, we can check if the number is present in that particular data structure or not. So this is that particular data structure, and we keep on inserting the elements, and once we find that particular element in the data structure, we return it. So for each iteration of the loop, we check if it is present or not, and due to hashing, this particular check is performed in constant time, which is O of 1. So the time complexity of this particular code is O of n. However, here we are storing all the elements in that data structure, right? So The worst case is that we insert all the elements into the hash data structure. So n elements are stored. So it takes the space of O of n. That is the extra space that we are using, right? So it will run for O of n time complexity, as well as it will take O of n space. So this is the most optimal solution for the this particular problem. Now we optimize it from n square to n log n to n. So this is how you must think in terms of solving a particular problem. And what if you were told that uh, you can the algorithm can run for longer time, however we have space constraints. So instead of using hashing, we would move to the sorting approach, because it takes, even if it takes n log n time, it solves the problem in constant space, right? So it depends on what the requirements are. And what happens if we have only distinct elements in the array? So that is just an extra edge case. In this case, there won't be any duplicates. The worst case time complexity would be considered for all the algorithms, because it will iterate over all the elements, right? Now, what if the array was already sorted? Would you use hashing? Which approach would be most suitable if the array was already sorted? Yes. Yes, we'll check the adjacent elements, and the time complexity would just be O of n, because the sorting step is removed as the array was already sorted. And yes, just as I mentioned, if we don't want any extra space, we'll use the sorting approach. So this is how you need to approach a particular problem and keep on optimizing it as much as possible. So this was all for time and space complexity part. And these are just general tips on how you should start your DSL learning. First of all, practice, regular practice is must, because even if you learn different concepts, as long as you don't implement them, you won't be able to solve the problems, you won't be able to build intuition that comes from regular practice. So keep a goal of solving at least 3 to 5 problems per week as you get time, and you can start with easy problems, then move to medium and hard as well. Okay, and break down problems step by step. So don't try to approach the problem as a whole, try to break it down into small steps. Identify the input, output, and constraint, how we've approached this particular problem. We thought of brute force, then sorting, then hashing. So there are these are the steps we followed. So try thinking of optimizing it from worst to best approach. And yeah, that's all. You have to keep practicing on your own, because we'll be teaching you all the concepts here, and we'll be giving you few assignments, but your progress will totally depend on how you how much regularly you practice. So if you have any questions, you can ask. Any doubt, any queries? Okay. uh, how will the mid test be pattern? Okay, we'll tell you beforehand the mid. We'll be sharing this PPT after the lecture. I'll create the Google Classroom for you all, and the PPT will be sent on that particular classroom. Just a second. Attendance. Priyank, have you taken the attendance? Okay. Yeah, the attendance has been taken. Any more queries? Okay, then we'll end the lecture and we'll notify you when the next before the next lecture. Yeah, we'll tell you tonight.